Today's paper is KASNEB CPA Part 2 Section 4, CIFA Part 2 Section 4, CCP Part 2 Section 4, Quantitative Analysis. The paper was done on 27th, that was of Friday, May 2016. And the question of interest that we want to consider is one that deals with the normal distribution, and we find that question in question 2. So part A, distinguish between a univariate function and a multivariate function. That is 2 marks. Then part B, the mean weight of 500 packaging tins from a production process are normally distributed with a mean weight of 151 grams and a standard deviation of 15 grams. Then what is required? The number of packaging tins that weigh between 120 grams and 155 grams. That's 4 marks. Again, the number of packaging tins that weigh more than 185 grams. That's another 3 marks. So that's the question, and let's see what the solution looks like. Well, for part A of the paper, which was done in May 27th, May 2016, which requires us to distinguish between univariate function and a multivariate function. Now, a univariate function involves a single independent variable. For example, if we have the function f of x is equal to x squared, there's only one variable and it does not depend on any other variable, and that variable is x. The fact that it is singular makes it univariate. So univariate refers to singular. Now, a multivariate function involves 2 or more independent variables. For example, we could instead of just having x, we can also have y, so that we have 2 variables, x and y, and all these are independent variables. For instance, if we were to talk about independent variables, x would mean the height of a group of people, say 10 people, and then y also means weight of the same group. So in that case, we have 2 variables, height and weight, both are independent. So in that case, we call it a multivariate function. So that answers part A of our question, and it is 2 marks, and we move to part B. Welcome again to solution to this question. That's question of the paper was done on 27th of May 2016, and you have seen the answer to part A, having to distinguish between a univariate function and a multivariate function. Then here we are told, part B, the mean weight of 500 packaging tins from a production process are normally distributed with a mean weight of, so mean is 151 grams, N is the 500, and standard deviation is 15. That's what we are given, 15 grams. So this is grams, that's grams. Mean is 151 grams, standard deviation is 15 grams. Then we are required to get the number of packaging tins that weigh between 120 grams and 155 grams. So we know that Z is equal to X minus this over this. So what we'll do first is find Z of 120, which will be 120 minus 151, which is the mean, over 15. That gives us a value. Then the other range is 155. So Z of 150, when it's 155, will be 155 minus 151 over 15. So the first part here should give us about negative 2.06 recurring, 2.06 recurring. And it's a negative, it's a negative, it's a negative. because of this. So this minus this divided by this, that gives you that. Then here, this minus this, subtract from this, divide by this, will give you 0.26 recurring again. So it then means that we have defined the corresponding probabilities. So the corresponding z-scores. So z-score that corresponds to 120 is this. That which corresponds to 155 is that. So I want to use the probability that corresponds to, I want to read the probability that corresponds to this z value and the probability that corresponds to this z value. So I will say probability for z of 120 will be, if you read this from the tables, then you'll find that probability to be about 0.0193. And probability 155 will be, that corresponds to this z-score, will be 0.6057. 6057. That's the probability. So for us to find the number of teens that lie between this and this, we just subtract this from this, because the area, if that's it, and this is 151, and then I have 120, could be this is 120, and then this end I have 155, could be this 155. So it's this area. So that's why I will have to subtract the area from the tail to 155 and then subtract from it the area from the tail to 120. And that's why we'll have 0.6057 minus 0.0193 is equal to, that difference is about, if you work it out, it's about 0.5864. 0.5864. You need to be confirming this with your calculators so that you get the confidence of working through. Then if that's the case, then this is the area. But the question required us to get the number of teens that fall between that. So we'll multiply this by 500. And that should give me approximately, if I multiply it by 500, 293.2. That's approximately 293 teens. 293 teens. Gives me 293.2. That's approximately 293 teens. Then Roman 2, the number of packaging teens that weigh more than 185 grams. If this is the, and this is 151, 185 is there. So we want this area. So it means we are going to get Z is equal to, Z of 185 will be 185 minus 151 over 15. And that should give us, about, that should give us 185 minus, 2.267. 2.267. Actually, it's 2.26. 6 is recurring. So if you read the probability value that corresponds to this z-score, you'll see that the probability of Z185 is actually, you read it, and in this case, because we are interested in the number of packaging tins that weigh more than 185, weigh more than 185, it then means that if you read the one that corresponds to this, it will be about 0.9881. So this probability represents the unshaded part because it is from this tail, from where this tail begins up to 185. So that the number of tins is between, say, 0 to 185. That probability is 0.9881. So for us to get the answer that we require, we would have to subtract this from 1. So the whole of this area, we subtract it from 1 to get the shaded part, because the shaded part is what we want. So in that case, the required area, therefore, will be 1 minus 0.9881, which is approximately 0.0119. 0.0119. So for us to get, because the question requires us to get the number of packaging tins, we have to multiply it again by 500. So if you multiply this by 500, so the number of tins required will be 0.0119 times 500. And that's approximately 5.95. 5.95 tins, which is, if you can write it for convenience, it is 6 tins. And that's the answer. So up to there again, what you needed to check is what a z-score is, where you find it in your table, and then you get knowing how to manipulate the standard deviation in relation to the z-score, in relation to the mean, and you get here. And whenever, before you start handling such kind of a problem, it's prudent to draw. By drawing, you see the picture, and that assists you to do it. Up to there, I urge you to subscribe so that you keep in touch and updated with my latest releases. See you in the next video. Well, the corresponding Z values, we read them as follows. Let me first unmark this. Well, so for a Z value of negative 2.0676, we know that that's on the tail, the left tail. And so we check 2.06 and we find it 2.06, 2.06, 2.0 is here, 2.0 is here. So 2.0, so this is 0.9772. Okay, just, yeah, 0. Yes, that one, but 06, 2.06. So 6, we get 6. Where do we get 6? We get 6 here. So we add this 3 to it. So it's 0.9775. That probability, so we subtract from 1 to get our corresponding probability, which is 0.0193, as we saw in our working. Now for Z of 155, that gave us a Z value of 0.266. So we come here. So 6 would be somewhere. That's 0.6026. So we have 0.266. So we would have to check again under 6. So we add 23 to this, and that's what gives us a probability value that we specified as 0.6057. Then for a Z value of 2.27 again, 2.27. Now we check for 7. Check for 7, should be somewhere here. That gives us 27. That gives us a probability value of 0.9881, and that's the value that we used. And we subtracted it from 1 to get 0.0119, as you remember from our previous working. And so that marks the end of it, and we meet in my next video.